Scripting. Why is this even in here? Because I respect your time and would love to find ways to help you save time. Really, this line up here says it all. We're going to be running programs with different varieties of parameters, different combinations of parameters, and then making graphs from that and then drawing conclusions from that. If you do it through scripting, you can get this done in about 2 minutes. If you don't, then you've got to edit, put in the right parameters, compile, run, write down the numbers, then edit the program again, put in a different combination of parameters, compile, run, and it takes a couple hours. You can pick. If you have 2 hours to spend, then I guess I don't care. All right. But anyway, yes, that's why these notes are here. I would like to save you time. I believe your time is valuable. All right, so here's a couple of ways of going about this. They require you to do some modifications to your program. So a lot of times you put defined constants up at the top of your program. Okay, define the number of threads to be 2, define the number of sections to be 32. And oftentimes you do that because it's more clear what's going on than if you hard code constants down in your code. And so here you might say OpenMP set number of threads to numt, and then if you want to change it, you just retype another number up here and compile and run it again. But if you set things up this way, and I recommend you do this if not def numt, meaning if numt's not been defined, we'll use this one. Otherwise, use the one that's been defined because we can define it from outside the program. Here's how you do it. When you run compilers, and G++ is a perfect example, you can do a pound define from outside the compiler. That's what this is, minus capital D numt equals some value. Okay, that essentially does a pound define numt to that value at the top of your program without you having to do it. Okay, so this is a bash script in which we are looping through 1, 2, 4, 6, or 8 as our number of threads to use. And here we're going to compile the number of threads right into the program as numt, which means back here, when it gets to this, it will not do this pound define because, well, numt was already defined. And when it gets to this, it'll put in the number that you put in right here, which will be 1, 2, 4, 6, or 8. So we're looping through and we're running this. But we're building in that pound define of numt. Okay, and if to run this, we would say bash, the name of the scripting programs, whatever this file name is, script.bash. And like seconds later, boom, everything's been run. Okay, you can do this with nested for loops as well. Okay, and we're going to do that because we typically do 2 independent variables, number of threads or number of cores, and number of subdivisions, something up to do with the data set size. Okay, and so here's how you do that. You make an outer loop. This is in bash. You make an inner loop, and now you've got 2 of these minus D statements in your compile line. This will set, well, it'll do 1, and then it'll do s equals 2, 4, 8, 16, 32, and so on. Then it'll do t equals 2, and do s equals 2, 4, 8, 16, and so on. Again, this is a lot faster than you editing, compiling, and running your program. There are other ways to do it. This is the C shell. The logic is the same. The logic is exactly the same. It's just doing it with different syntax. You can do it in Python. Logic is still the same, just different syntax. And now there's a second way. One thing you can do is use command line arguments. So forget this. This was way number 1. this is going to be way number 2. So in the top of your program, you would do this. This makes global variables that have some default values in them. When you make your C programs really are supposed to have these 2 arguments. They don't, sometimes you just leave them out. You say main paren paren, but they're supposed to have this. And argc is the argument count. How many things are on the command line? Well, it's going to be at least one, the name of the program, but then it's going to be other arguments you might use. And then argv is an array, the argument vector, an array of the strings. So argv0 is going to be the name of the program, a string. And then argv1 is going to be the first argument. So if you use the Linux command ls-l, there's 2 arguments there. The first one is ls and the second one is -l. So what you can do now is you can use something like this. You run your program, space, the number of threads you want, space, the number of subdivisions you want, or whatever it is you're setting. And then inside your program, you're going to say, well, if there are at least 2 arguments out there, then I know the number of threads has been specified. And if there's at least 3 arguments out there, I know the subdivisions have been specified too. And now when you use those variables, numt and nums, they'll either have the default values if no arguments were given, or they will have whatever your arguments were. Easy. All right. This isn't going to make sense now, but it will when we get to OpenMP. But yes, if you use method 2, then nums is a variable. It needs to be declared as shared in the OpenMP pragma line. All right, you can forget that for now, but it'll show up later. All right, setting up your benchmarks. Well, when we go run these things, with the real purpose we're doing here is to set up your benchmarks. So here we are running them from the bash or from the C shell or from Python. And that gets you through all the combinations that you'll need. Now, a lot of times people think, you know what, I don't want to learn how to do that scripting. But what I'll do is I'll put for loops in my C program for all the combinations of parameters. And that sounds like it ought to work, but don't do it, because I've seen evidence that OpenMP actually does some amount of setup the first time you do something with it. And so if you're doing multiple combination runs out of one program, the first combination will take longer than it should. And then the others will be faster than they should, and it'll mess up your timing. Do one parameter combination per program run. Do it the way that you just saw here. Now, diverting to a file. If I want to run that bash script, then I would do that, bash script.bash, greater than ampersand, that diverts both standard output and standard error. Anything that's been printf'd or fprintf to standard error will come out and will end up in this file. So that's a really good thing for you. Even better is if you create something called a CSV file. CSV is a comma-separated variable file. So instead of maybe putting in spaces between your numbers you're printing out, put commas there. And the reason is CSV is a file type recognized by Excel. You don't even have to read this file into Excel. If you just double click on it, like you're in Windows, if you just double click on it, Excel will pop right up and read it in. Now, I recommend you do printing with words in there so that as you're debugging your program, you remember what your numbers mean. But then when you're all done and ready to get your data, comment out those verbose print statements and just put in the numbers with commas. Okay, then you'll just read these right into Excel. And so if I do this, this is what my out.csv file might look like. You know, number of threads, data set size, performance. And if I just double click on that, if I'm in Windows and I just double click on that, here's what I get. It just sucks it right into Windows. Now, it is not in the form you need. And for that, we're going to look at the data set called pivot tables, which will just automatically turn that into the form that you need. But at least you've got it in Excel. You've got all the variables separated out, and it's all into Excel. And again, warning, if you're on Windows and you type in a Linux script, Windows will put an extra character at the end of every line, which Linux will not recognize, and you have to fix it. And there are 3 ways here to fix it. Okay, so that tells you about running scripts and really learn the scripting. Yeah, I know it's 5 minutes and to learn something you've never done before, but it will save you hours over the course of this term. It really is going to be worth your while.